Uh, yeah, okay. So I'm going to be finishing off the analysis of variance for the two-way testing. So we already did the one-way ANOVA testing. It is very similar to the one-way ANOVA testing, but this is obviously two ways. Um, so the difference is that in one-way ANOVA, we only had one variable which we were testing. And out here, we have the each samples are defined in two ways, and then we divide them into two different category groups. So basically, this is basically used when you have two independent variables and one dependent variable that you have to find the relationship between. So like for an example, you can take something like if you want to see that if a plant growth is influenced by sunlight exposure and watering frequency. So basically, your dependent variable becomes your plant growth, and your independent variables basically become your sunlight and your watering frequency. So you want to know the relation between these three variables. So your response variable is basically called your plant growth, and the factors are your sunlight exposure and your watering frequency. Now, last time in the NTOM exam, so she had asked us assumptions for one-way ANOVA. So these are the assumptions that I've mentioned for the two-way ANOVA testing. So the first one is that response variable is approximately normally distributed for each group. So yeah, sorry. So is normally distributed for each group. Then the second one is equal variances. So the variances for each group should be roughly equal. Basically means that sunlight and watering frequency ka variances are almost equal. And the third one is independent. That basically means that the observations in each group are independent of each other, and they were obtained by random sampling. So sunlight and watering frequency have nothing to do with each other. That is why they're called independent variables. So now I'll share and I'll show you how do you solve this on Excel. So we just have to use the Excel formula. We don't have to use the Excel formula. So yeah, so the question is that basically a company produces stationery items and now wants to go in the photocopy paper manufacturing business. So now they want to test the market in the product, or the market and the product for three areas, namely North, Central, and South. And they want to take a random sample of 5 salesmen, S1, S2, S3, and S4, S5 for this purpose. So now in this table, they have basically showed that what is the sales generated in each of the regions by each of these salesmen. So salesman 1 generates 24 sales in the north region. So this is what the table essentially means. And this table is given to us. Okay. Now the question is that you want to basically figure out if the salesmen are performing differently and if the regions have a different sales capacity, right? So basically, the end of this entire thing is to see if the way the salesmen are, like, is salesman 1 different from salesman 2, stuff like that, or all the salesmen are the same. And they want to check if North, Central, and South have different selling proportions, if North is doing better than Central or better than South. That is basically they want to check, and they've given 95 confidence level. So the first step that you have to do is you will have to find total of all your rows and of all your columns. So basically your salesman total is the sum of your first column. So similarly, you will be finding S2, S3, S4, S5. And out here, you will be finding the row total for all the regions. After this, you will be finding your block mean. So block mean is basically your rows, each of the rows ka mean. So it's pretty much like 135 divided by 5, right? Because there are 5 of these. And your treatment mean is basically your salesman's total, like your column total divided by 3, because there are like 3 rows. Okay, so basically your block mean are your columns total, block column total, and your treatment mean are your row mean. Okay, so now the step 2 is to find out the number of rows, which are 3, North, Central, and South. Your number of columns are 5, and the big N is basically your rows into columns, that is N into C. Now the step 3 is to define your hypothesis. So the first, you'll be defining two hypotheses with this one, since we have two different variables. So we have salesman का एक hypothesis निकलेगा और दूसरा region का hypothesis निकलेगा. So for the treatment, you are going to be talking about that. So treatment was basically for all of the salesmen. So you'll be saying that the means of the salesmen are equal, and alternate hypothesis is means are not equal. For the block is the regional sales are equal and means are not equal. So regardless of what sums you get, the hypothesis will remain the same. The null hypothesis is basically your means are equal, and your alternate hypothesis is basically your means are not equal. So this is common and consistent throughout any sort of sum that you guys will be getting. Now here comes the very lengthy part on how to solve this. So the step 4 is basically your sum of squares calculation. So what I have essentially done is I've copied this entire table back out here. Okay, now we have to find 4 sum of squares. The first one is column, then rows, error, and total. So out here I've given the formula for each one of them, and we'll be using Excel to solve this. So essentially you're not allowed to use any sort of formula, like any sort of functions of Excel to solve this. So we have to like pretty much like manually like solve this using like this formula itself. So for your columns, here, so basically your columns are your treatment means. So basically first I'll be doing for these 23, 30, 26, 23.3 and 31.67. So the first step is to find xj minus x bar. So sorry, I forgot it earlier. Ki x bar is your grand mean. So grand mean is basically you take your average of your block means, or you either take the average of your treatment means. Both of them will give you the same grand mean essentially. I just took the block mean because it's like divided by 3, which is easier, but does not matter. So yeah, so this is your grand mean. So basically your x bar is your grand mean. So this first thing that I've done is basically I've minus. So what you have to do is you have to minus each of your treatment means by the grand mean. So this is 23 minus 26.8. Then this one is 30 minus 26.8 and so on and so forth till the last. So for all 5 of them, you have to do the same procedure. Then you have to square this value to get these values. So you're going to be performing square, and then you have to total the squared values. So this is the sum of these values. So basically your sum SSC ka second half of the formula you have gotten, which is 61.02. You multiply this by n. N is basically, we've defined it as number of rows, which is 3. So this is just a basic formula that we'll be using. Okay. The same thing you do for your block means. The block means you'll be dividing each of your block means by the grand mean. So yeah, so this is what I've done. Then you will be squaring all of the subtractions. You'll be finding the summation of the squares. So this is basically the sum of this. And for your SSR, the sum of squares for your rows, it's C into this value. So which is C is your 5, which we've defined here, number of columns into 1.04. So that gives you SSR. Going to SSE, now this is a bit tricky part, SS error. So the first thing I have said, xij minus xi plus x bar. So xij basically means xi's are basically your rows and j's are basically your columns. So xij, so x11 is basically 24. Then x12 is basically 30. So that is how you're going to calculate for each of these values. For each of these values, you will be calculating this table. So the calculation is simple. So what you basically do is you take xij, you subtract it by your block mean for that row, you subtract it by your treatment mean for that column, and you add your grand mean to it. Okay, so 24 minus 27 minus 23 plus 26.8. So you do this for each and every column. So I'll take this also. So for 22, you'll be subtracting minus 26, minus 23.3 and plus 26.8. So this is how you will be filling your table. So this is a very tedious task. Make sure you make a template of this and keep it ready, because I don't think you will be getting the time to do so many calculations out there. But yeah, after doing this, you find the squares of each of these values, and then you find the summation of the entire square table. Cool. So that becomes your SSE. Now the easiest part is your SSP, total sum of squares, is basically the addition of these three values, column, rows, and arrows. So the summation of these three values will give me my SSP. Now the step 5 is your mean of squares calculation. So your MSC is basically SSC minus C minus 1. So yeah, so SSC minus C minus 1. So C is our 5, so 5 minus 1. So I've written down the formulas out here. So it's the same thing that you do for MSR and MSE. Right, so you find your mean of squares calculation. Then you go and you find your F observed. So this F observed is basically your final step, which you'll be comparing with your table values. So there are two F values that you'll be calculating. Since we have two hypotheses, we'll have two F observed values. So your first one is FT. Your FT is basically your treatment, and FP is your blocks. So your FT equals to MSC upon MSE. So MSC upon MSE, and your F blocks are your MSR upon MSE. Right, so you have these two values. Now after that, you will be finding your F table values. So your F table values are basically, yeah, sorry. So F table values you'll be defining. So the first F table value is your 4,8. So how do you get this 4,8 is basically 4,8 is basically your C value. So that is C minus 1, comma, N minus C plus 1. So this is basically right. So this is 5, 1 is 4, and 15, 5 minus 3, that will give you 7. 7 plus 1, that is 8. So this is how you get your F4, 8. Now you will have to check the F table value. So your F table will look like this. You will have to find the F table for alpha equals to 0.05. So we need to find for F4, 8. So my first degree of freedom, BF1, is 4, and my second degree of freedom is 8. So this is the value I get, 4, 8, which is 3.83 or 79, right? So yeah, 1 second. Okay. Yep. So this is the value. And so this 2, 8 is basically my n minus 1, n minus c plus 1. Yep. So these are the two values about how I got F2, 8. And then you again see your F distribution table. So 2, 8. So 2, 8 is 4.4590. Right. So these are the two F table values I have gotten from the table. Make sure that you see what kind of alpha value has been given to you. So we have been given 95% confidence. That means alpha is 0.05. That's why we've taken it. But yeah, if they haven't given it, you can just assume alpha to be 0.05. So now the second last step is you'll be comparing your FT with your F4, 8 value. So we can clearly see that 30 is obviously greater than 3.8. So your null hypothesis is rejected because it does not lie in the acceptance region. And for the similar way, we see that F2A, so 4.4 is greater than 1.7. So we accept the null hypothesis. So the null hypothesis that we have defined for the first one was that means of salesmen are equal, but we're rejecting this. So basically means that there is a significant difference in performance of salesmen. So obviously the way salesman one performs is very different from how salesman five is performing, or for any, we don't know exactly which salesman is doing better than what, but yeah, but we just know that they're not performing the same. So each salesman has a different sales output, but there is no difference in the performance of different regions. So this basically is that all regions, whether it's north, central, or south, all of them have the same sales like the same volume. So all of them are performing pretty similar to each other, right? So this is the entire ANOVA testing, ANOVA test. So yeah, I would suggest you all to make a template already. Probably solve it once, or have a template. Take a table which has bigger values, which is like 5 comma 3 or something, because what happens is, if you're not, so it's better, because even if you're using the first 3 columns, your entire solution stays the same. But yeah, so prefer doing this sum is pretty good. This is one of the CP problems. So try solving and keep it ready, because tomorrow you will not have the time to sit and do it. So yeah, that's two-way ANOVA testing. Thanks.